Not joking. Dylan. No. Number 69.
No, what? Well, I needed 12. We didn't even do 60.
We had 70 B.
Because we left off with 7.
That was dumb. I found the answer.
No, really, John?
Allison was right. All right, 69. Find the value of dr dt at t equals 0 if r equals theta squared plus 7 to the 1/3 and theta squared t plus theta equals 1. Is that right? Okay, find dr dt. We've got two variables here. The two variables are theta, so I'm going to do some implicit differentiation. In other words, I'm going to start deriving with respect to certain variables, right? All right. I would probably do dr. I would do dr dt. But I'm going to have to take into account that I have another variable in here, right? So when I take the derivative of r with respect to t, well, I'm going to have to do, so I got 1/3 theta squared plus 7 to the negative 2/3. Chain rule. But this one's going to be d theta dt. Well, because I need the derivative. Remember, I'm with respect to t. It's not right. Kind of like when I'm doing the derivative with respect to y. I mean, with respect to x. Anytime I take the derivative of y, I have to do dy dx. Do what? No, don't chain rule it again. That is the chain rule. So this is 2 theta. Oops, let me do 2 theta over 3. You don't have to rewrite it. Right.
But how do you isolate it?
Well, I didn't isolate, I'm just multiplying by it. So what I'm thinking now is I can solve this one. I can take the derivative of this one with respect to t, right? Okay, so tell me what I do then.
I just don't want to make a plan of events. I don't know about the exact thing. Let's see. All right. Well, if you're doing the derivative, you're going to have to go a little bit implicit.
You are.
So it's
with respect
product rule right there.
Okay, so this is, yep, so derivative of just this one.
Oh, well, it's just 2 theta. Yeah. Then you product rule? Oh, no. Like,
Times t.
Okay.
This is product rule plus theta squared. What's the derivative of t with respect to t?
It's just this form.
It's just 1.
Yeah.
I'm doing the derivative with respect to t. Because what I want to do is I want to find out what d theta dt equals so that I can plug it in here.
Then you got plus 1 to actually d theta dt, right? And you got equals.
Right. Plus d theta dt equals 0. Sorry.
Simplifying here.
Y'all see where we got that and what we did?
Heck yeah.
I'm just deriving. I'm just deriving to see. I know what I want to find. I want dr dt. And I know I have an equation for r. So the first thing I did was derive that with respect to t, dr dt. Right? So this equals dr dt. Do you agree? Right.
You need to plug in for d theta dt. Whatever this is going to equal d theta dt.
Right. So I'm going to need two things here. Okay? I'm going to need d theta dt. I'm also going to need theta when t is 0.
Yeah.
Wait.
You just plug in for that. You just plug in.
Mm-hmm. All right. When do you see how we derived the first one? We're looking for dr dt. That's the goal. Mm-hmm. Mm-hmm. Well, but we're gonna have some thetas in here. But let's go ahead and do that, and then we'll talk about the theta thing because I don't want to throw too much on you one. All right. So if I go through this one and I solve it for d theta dt, y'all with me? But I'm gonna plug in a 0 for t. Might as well, because I've already taken the derivative.
Well,
That's going to take out that whole first, right?
Yep.
All right, so now I've got theta squared plus d theta dt.
Equals d theta. Yes.
Now, what I might do here, before I even plug it in there, is I might think, well, look at that second equation that we were given. Look at this one. We know what t equals. Could we find out what theta equals when t is 0?
We could. Plug in 0 for t right there. Plug in 0 and then
So,
theta equals 1.
When t equals 0, theta equals.
No, that's not the derivative.
That's not the derivative. That's not the derivative. But that's an original point, right? Can I do that?
Well, then I guess you can plug in theta right there.
So,
you can plug in a 1. I mean,
d theta negative 1.
no, we're looking for dr dt in this equation.
So d theta dt when t equals 0. If you square it here and then you move it to this side, it's negative 1. This is negative theta squared, not negative theta squared.
Oh, okay. All right. I got it. All right, so now you plug in that negative 1.
2 times negative 1 over.
Well, it'd be 2 times negative 1 times negative 1, right, Miss Media?
Oh, no, it's positive 1. You're right.
And then times
D
negative.
theta dt is negative 1.
Oh, God, I thought that.
So you got to plug that in too, though.
All right, look. Theta 1.
Yes.
If you square 1 and then you move it over here, that means d theta dt is negative 1. But all my thetas are 1.
Oh, God. Yes.
I'm doing all that.
Hey, that sucks. I don't like you. I'm not.
What's 8 to the 2/3?
8 to the 2/3? Well, I would have to guess that would be around 5.
What's the third root of 8?
Third root of 8.
Squared.
Well, you got Things of that nature.
8 to the 2/3, the third root of 8 squared.
I've never been taught that.
You think I know how to do that?
I just think I know exactly what is 8.
Oh.
What makes you think I know how to do that?
So all this we've done, and this is where you go, oh, you're doing voodoo,
Yes.
Miss McGee.
But I would just leave it.
Hold on.
I would leave it like, I put a negative in front of it. Like that. Oh, I haven't even written this down.
You are lying.
I've
Tell me
been
that's the answer they
engaged.
got.
Can I get a pass for this question? I have been seriously engaged on this one.
Why don't you go ahead and copy this real quick?
All right, whatever. You're gonna sit there.
Okay, we'll sit here for just a minute. Well, you got to clean it up a little bit. So this would be 1 over the square root of x times 1 over 2 times the square root of x. Because this becomes positive and goes to the bottom, which becomes 1 over 2. The square root of x times the square root of x is x. I hope that's what they got. You don't know. Well, here's the problem, Vin. On an FR2, they would most definitely give you credit at stopping at this point. But more than likely, this type of problem is going to be a multiple choice question. I might give y'all a little Barron's work tonight.
No, that'd be good. No, do that.
7 pages.
Give us.
Well, but I need you. I think everybody needs
Well, we also we have college apps that are due today. They're due today.
All right, let's continue on. Questions about your homework.
70C.
70C. Man,
I'll tell you what I am.
no, we don't want to know.
Oh my gosh.
I'm disliker of people named Dan.
My dad just said Dr.
No, he didn't. All right, number 70, part C says what points reached by the particle are the farthest to the left and right of the origin? This is what we were doing on Friday, wasn't it? We did part B. So part C, Allison's thought process was exactly right. We need to know the maximums and the minimums.
Oh, I'm not doing this.
It's not as bad. Do I? Well, this one's not too hard.
We spent 30 minutes.
You'll probably definitely have a particle motion on the test. All right, so farthest left or farthest right, we're looking for those maxes or mins
What was that max
and
max or min?
of the position function. So the highest point on position would be the furthest away, right?
Yeah.
All right, so we're looking for when, what's my equation? So it does include that 10. So what we're thinking is we know, remember when we did that sandwich theorem thing that we did where we put it in the middle and we said, okay, we know that this one is always between -1 and 1, right? So if we had it like this, so thought process here, maxes and mins of the position function would give you that furthest away. That's the maximum position, the furthest it goes. So this is not the answer. What I'm saying is it's oscillating between -1 and 1, right? But the actual
That would make sense, though.
Yeah, aggravation. But there's like more stuff to do.
okay, so where is the cosine of this? Let's ignore the 10 for right now because I threw y'all with that sandwich theorem. All right, where is this? Then we'll worry about the 10 in just a second. We don't know. That's what we're trying to find. What is t when this is 1, or what is t when this is negative 1? Well, where is cosine 1?
Zero.
At 0?
One.
It's at 0. It's at 0. It's at 0, right? So the cosine, so this means, think about it like this. Did y'all didn't solve? Okay. I think about it when I'm solving an equation like this. You do the inverse on both sides, right? So you do t plus pi over 4 equals the inverse cosine of 1. In other words, where is cosine 1? And cosine is 1 at 0. To get rid of the trig function, you can inverse both sides because that's going to cancel out there.
Oh, that does make sense, actually. That's pretty good.
I don't know any of them.
Any of what?
We gotta use them twice.
What?
No, you can use it on the quiz, but not on the test.
I haven't able to.
School's hard.
Make some flashcards. Make some flashcards. Okay.
I don't have time to.
So,
Better do it. Better do
Well,
it.
I'm not the one having a flash.
You're so right.
Wait, so I was getting
You're right. I don't need it. Yeah, I'm gonna cheat.
if I need to solve with some trig functions in there, okay, in order to get rid of a trig function, if I have the sine of x equals 0, in order to find out what x is, I can do the inverse sine on both sides. That's going to cancel this out here and just leave x and leave me with inverse sine on this side.
Are you dividing it?
You're not really, you're just taking it's like this, the inverse sine of the sine of x. You're taking the inverse sine of both sides. What happens when you put inverses together? By definition, inverses do what? What's the inverse of a? You are. Okay, so inverse sine says, where is the sine this value? That is what inverse means. If I asked you what is the inverse cosine of I'm asking you, where is the cosine value the square root of 3 over 2? Where, so this one is asking, where is sine 0? This leaves me x, and this says, where is sine 0? Well, where is sine 0?
At, where is sine 0? Oh, at 0.
At 0. If I'm looking at this, where is the cosine the square root of 3 over 2?
I forgot. It's like right, up and right.
All right, so let's think about it. We have pi over 6, pi over 4, and pi over 3, right? This one goes out further on my x. So this is square root of 3 over 2, 1/2. This one is 1/2 square root of 3 over 2. You guys have to know your unit circle. So the cosine, where is cosine square root of 3 over 2? Pi over 6. Well, let me just finish saying about this one. If you have your t value for your max and your min, yes?
Yes.
All right, so I've got my t value. What I'm going to do, I'm going to plug this in. I hope this works. Bless you. To my position function. So I'm going to do s of pi over 4 to find out where it is at that time.
Wait, would t negative pi over 4 and pi over
Yes,
4?
because
What,
one's
and
to the left and one's to the right. It says the furthest left and the furthest right.
So those are maxes and then. so
Right,
plus or
right,
minus.
right, right. So if you plug this in, you get 10 cosine, bless you,
with that.
of,
Bless you. Hey, you were the fact.
y'all are, plus pi over 4. Is that right? No. So we got 10 cosine of 2 pi over 4, which is pi over 2. So what's the cosine at pi over 2?
That's
0.
No, that's
0.
That's 1/2. That's 1. No, it is 0. You're right.
Wait, why is this not working?
Just make it a derivative.
Yeah, no, that.
Of cosine, which is negative sine, and then.
No, why would it be?
I'm on the step I'm on is never
Someone said, are we
the inverse cosine of the sine.
even though I'm bad at math, I'm not just a fool.
When does that equal 1? And we said that equals 1. Where's cosine 1?
That's not 1, 0.
So we should be able to plug that. If you plug it into the derivative, that's velocity.
Why do you find
We wanted the maximum and minimum. So cosine has maximums and minimums at 1 and negative 1.
because I know we said that in the
Just because we know about the cosine function. Cosine and sine always have maxes and mins at negative 1 and 1. No.
So what did we end up like? Where did we go? Like,
I skipped over that because everybody's eyes were glazing over, and I said, okay, let me approach it a different way.
okay.
All right.
In solutions, I believe they went to pi over 4, and then you get 1.
The inverse cosine of 1. Where's cosine 1? That's at 0. Okay, so let's see. If I plug in negative pi over 4 into the function to find out where it is, that means my maximum happens at pi over 4 in time. That's my seconds or whatever it is. Then if I plug that in, I've got 10 cosine negative pi over 4 plus pi over 4. This is position function. So I got 10 times the cosine of 0. Right? That's one of the answers. That's the position, I don't know. So yes, that was the maximum. That's when we plugged in the maximum to see when is it 1. Okay. So now we need to do when it's at negative 1. So where is the cosine of t plus pi over 4 negative 1?
What's it? Negative 10?
3 pi over 2? That's what we did wrong before.
What?
Where is the cosine negative 1 on your unit circle? At what? It's at 0.
It's at pi.
So cosine, so t plus pi over 4 equals pi. Now I can subtract pi over 4, so it leaves me with 3 pi over 4. Now plug that in to my position function. You should get 3 pi over 4 plus pi over 4. What's the cosine of pi? No, what's the cosine of pi? Negative 1. So 10 and negative 10. There we go.
Well, I said negative 10. Okay, we do 15 now. This is
All right.
cool.
We could have used the sandwich theorem. That's where I was going with it. We start with knowing that, and then it was way easier to use the sandwich theorem on that one for sure.
We don't like
But okay, we don't like sandwich. Okay, 15.
I'm talking about 15. Like,
I'm so sorry that I have been in and out today, y'all. Y'all are so understanding. All right. Find dy dx. So we do e to the, remember this is e to the blah. Now we got to do the derivative of the blah. What is the derivative of 1 plus? The derivative of 1 is 0.
Right, that'd still be in the.
Wait, what?
That would still be on top, right?
Now, you might look at the answers and go, whoa, how did they get that? And you have to know how to manipulate, because on multiple choice questions, that's what they're going to do. You're going to have to be able to manipulate. Okay, let's think about properties of exponents. So all the way back to algebra 2 again, right? If I am adding those exponents together, then I could be, you're exactly, so I could split this up.
How did you put that in? You put that. They're not still being
No, it doesn't become an exponent. It's e to the blah times the derivative of blah. But it's equal level.
like a little bit. Well, it is changing.
Yeah, here we did. But now what I'm doing is I'm splitting this up. If I'm adding the exponents together, think about, I'm really going backwards on that rule that says if they have the same base, then I add the exponents. What I'm doing is, since they're already added, is I'm splitting them back up. And the reason, no, you wouldn't power rule. Anytime you have e as the base, you don't power rule. Not like that. Okay, so this is convenient, and the reason I would think to do this, or you should think to do this, is whenever you see natural log as the exponent, you automatically start thinking, wait, that's a log base e, and it probably is going to work together with the base of e somehow to cancel out. And in fact, e to the first is e. What does this become?
That becomes x to the e to the other. Well, it'd be 1.
If you have 2 to the log base 2 of x, it becomes x.
I really want to know how you do that. I don't understand this. Like, how do you know that?
So it becomes x. Do y'all not remember? Okay. If you have a base, okay, if you have a base and it's raised to a log with the same base, all of this cancels and leaves you just with this.
Well, the natural log is e.
The natural log is log base e. What other x?
When did that ever happen?
When did whatever happen?
It's an e and an x. How do you cancel the e out like that?
Yeah. So if I have e to the log base e of x, all of this would cancel and just leave me with the x.
Yeah, but that's what you didn't have that.
Yeah, I did. I had natural log of x. Natural log of x is the same thing as log base e. You at least know that, yes, the log base e and the e.
I'll do my notes. I got a lot of things to mention.
Did y'all not talk in? No, I'm not talking about in here.
Wait, wouldn't the answer be e?
So, yes, the answer would just be e, because x times 1 over x, 1, so it just leaves me with e.
Well, you see what will happen is the x would go on top, and x divided by x, well, anything divided by itself is 1. Except for 0, which
You
would be
scroll
like
just a little bit so I can write it
now.
down.
Even though 0 divided by itself is 1. Now,
Lizzie, what do you got?
Tell me when you get it, man.
this is your 21.
Yeah, I'll just write it down later. Just go ahead.
No, all right.
What are you writing down, Lizzie?
I wonder what busy ones are.
Any thought? Yeah.
All right, which one did you say?
I'm not gonna buy it.
33? Well, then you'll have plenty of time to study for math.
Oh,
Look.
that's exactly what I'm doing.
I did that.
That's literally exactly what I'm doing. And I do that every day.
I feel like we did this one Friday. Did we not?
We did 34.
Okay.
We did 34.
We're looking for the values for which x is differentiable. So, I know that the bottom can't be 0. That's the first thing I would look at. I'm looking for undefined points, essentially. Here's what I'm looking for. What? Okay, so, yeah, but is that ever going to be 0?
Well,
Yeah, that's an identity right there.
What?
If you
I
would,
thought you would. I just manipulated the denominator tangent.
it would just be when
I don't know if you
negative
feel that or not, but I saw that.
Well, I'm glad you saw that in there. No, I am really glad you saw that in there. But we don't have to take the derivative.
it would actually I might do the wrong thing.
Yes, it would be the right. So, yes, if you want to do that, Dylan, you're more than welcome to. It's not really going to do you any good here because I'm looking for undefined points. I'm looking for points that are.
I'll just want that, the 1 plus x squared here right there. I'll just stand that. I was just like letting you know. I figured you knew already.
What are we doing? Implicit.
What are y'all doing? Find all values of x for which the function is differentiable.
Yes, you said the bottom is 0. Like, what is wrong?
So the bottom can't be 0, but what else do I have? What other type of domain restriction do I have here?
Well,
What are they?
Maybe one of them cusps.
Maybe one of them.
It's just square root. That would mean that it can't go past, like, I don't know. Oh, well, yeah, it has to be greater than or equal to
Good.
0.
No, I want to make sure that the bottom can't be 0. I'm looking for points where I'm not defined. This is a no calculator.
So how do you remember?
So you're looking for, well, what I would say on square roots and things like this, look for places, keep your radical positive, keep your denominator not equal to 0. Look for points like that. And then you also know when I'm talking about square roots that generally look like that, right? This starting point is not going to be differentiable because it doesn't have a left side derivative. So instead of greater than or equal to 0, it's going to be just greater than 0.
Sure.
Because it's differentiable, not just defined.
Okay, so what's the answer?
Okay, so let's solve it. So I've got an inequality here that I have to solve. So I'm going to square both sides. Okay. And I am probably,
Multiply the right side by 1 plus x.
by 1 plus x squared.
So the answer is going to be x is less or greater than 1.
No, it's less than negative 1.
No, it's not.
It would change signs. When you divide by a negative, it changes signs.
You're not dividing by it. You're adding.
Did it?
It's going to be negative x.
No, it's not, you moron. Listen, Dylan, multiply the 1 plus. Ignoramus.
Well, it's 1.
Dude, we changed the sign, though.
We did change the sign.
We divided by negative, so we flipped the sign there, yes. So there, I have to stay bigger than negative 1. 53? We just did total algebra 2 concept with the domain there. We set the bottom equal to 0 to leave it out of the domain. If the points aren't in the domain, it can't be differentiable there. And then we set it greater than or equal to 0, but instead of greater than or equal to, we just did greater than, because that starting point is not differentiable.
I get tripped up when you don't have to get a derivative. Like, 'cause I feel like I just always do it.
You could say differentiable when x is less than negative 1. You could say differentiable when x is negative infinity to 1. There's not a set notation that is acceptable and one not acceptable on the AP exam. You can do it. I mean, if you literally wrote it in words, they would take it. Because anything negative under a radical is going to be imaginary, and if it's imaginary, it's not on the graph, so it can't be differentiable if it's not on the graph, right?
No, it's not.
What do you mean? So I'm basically, so we did one of those on Friday, like number 34, where it's 1 over 1 minus e to the x, and essentially all we did was look at the bottom to see if there were any places. And you'll use your knowledge of the function itself. Like on 32, it's sine e to the 2x. We know sine is always differentiable because it's always continuous going there that way. 53?
Nice. Like, it's still over there.
Sine of ax plus b cosine x when x is less than 0. 5x plus 3 when x is greater than or equal to 0. If f is continuous at x equals 0, didn't we do one of these on Friday, but it was an m instead of a... Okay. Okay, I'm sorry. All right, so f is continuous, so tell me continuity means what? The limit is the same from both sides as well as the function value. So the limit as x approaches 0 from the left must equal the limit as x approaches 0 from the right, which must also equal this. The specific function value there. So as I come in from the left, it has to be the same as I come in from the right, which has to be the same if I plug the value in. That's the definition of continuity. I can guarantee you a question like that on the AP exam. Somehow, some way, they're going to test you at least one time, probably more, if you know the definition of continuity. And that is the definition of continuity. Okay, so find the value of b if the function is continuous. So if all of this is true, find the value of b. I don't know why b and not a, but okay. So what I'm going to do, since the limit, I can use plug in for both limits here, right? I'm going to say, well, if that's the case, then the sine of a times 0 plus b times the cosine of 0 must equal 5 times 0 plus 3. The left and the right have to equal, right? All right, so this is sine of 0 plus b cosine 0 equals 3. Well, a times 0 is 0.
What's the thing times 0?
The sine of 0 is what? At 0, how much height do I have? 0. What's the cosine of 0? 1. So what's the value of b? What did it ask me to find? Yes, because if I do the left-hand limit here, because this is a sine plus a cosine, I can use plug in there. And I can also plug in here. It's saying that it's continuous. That was the key to this, is that it was
What does it
continuous.
matter that it's time?
Because that kind of tree function is continuous, and it not continuous, but I can use the plug in to. There's no holes or discontinuities there. I can just plug into that one to find the value.
I think fine is also less than 0 and greater than 0. What?
If f is differentiable at x equals 0, find the value of a. So now my equation is sine ax times 3 cosine x. The value of a. So this time, same deal, right?
That's going to equal 5.
Wait, it's still 53, right?
Right, it's still the same. Still, if it's differentiable, then it's also, so now I need to know, this is what? Yes. So if it's differentiable, then the left-hand derivative and the right-hand derivative have to be the same. Do you agree with that? Well, it says it's differentiable at x equals 0. Find the value of a. So what is the left-hand derivative? What is the derivative from the left?
Less than 0.
Cosine, yeah, ax times a plus.
Where would you get an A from? That's something blind. There's an A inside the sign. We just do the chain rule. Yeah, where's the first part?
The left-hand derivative.
Oh, shoot. Oh my gosh, I didn't realize that was derivative.
The left-hand derivative of f, right? This, I'm using this one for the left-hand derivative. If it is differentiable at 0, this is another one. You have to understand the definition itself. Definition of differentiable says that the left-hand derivative and the right-hand derivative are the same at that point. So the left-hand derivative would be the derivative from the left. So that is derivative of sine is cosine.
So this must be the positive.
And then times chain rule it. So this, what's the derivative from the right? It's 5. Okay. Well, I know that x is 0, right? It says when x is 0. So I know that a cosine ax minus 3 sine x must equal 5. Because the derivative of 5x plus 3 is 5.
Where's the 0?
I'm fixing to plug in 0. Now I'm going to plug in 0 for my x's because it says when x equals 0. So a times the cosine of a times 0 is 0. 3 sine 0. What's the cosine of 0? What's the sine of 0?
So that means you have A.
And so that means that here we are continuous and differentiable.
But C asks us, if x equals 0, is f differentiable if x equals 0 at, is f differentiable at x equals 0 if a is 5 and b is 4? Well, we know a being 5 is okay, but is it okay that b is 4? Justify your answer. That's exactly right. So if you plug in 4 for B and 5 for A, what happens is the left-hand limit and the right-hand limit are not the same. The derivatives will also be different at that point. So the answer would be no, because it says justify your answer. No, because it's not continuous and it's non-differentiable, right?
Did it ask if it's one but not the other?
No, is it differentiable? But in order to be differentiable, you have to be A, continuous, and B, differentiable. So that's why you had to do A before you did B as you answered that question. The limits have to be the same.
So if it's questions like that, we can like
Yeah, this could possibly be part, I have seen this come in FRQs before where they have variables in there and they question, like part A would be the definition of continuity or differentiability. And then they would use those values to fill in the equation, and then you do things from there, like if this represents the position function, find the velocity of the function at the, after you've already answered something. But I have seen these type piecewise questioning because that's a huge concept. It's a big concept in calculus is differentiability and continuity. Well, because three main concepts in calculus: limits, derivatives, and integrals. Chain rule is part of derivatives. All right. I got time for one more, and I'm off. Choose wisely, young Padawans. What?
I'm so tired. I just want to go home and sleep some more. She has like 30 seconds. It's in her hand. I can see a question.
I was gonna say I'll unplug and tell you topics you need to.
Yeah.
So what do you?
I'll have to put it. I'll give it to you. It's gonna probably be from parents.
It's fine, Aaliyah. Aaliyah,